Hi guys, so we're going to learn about how we're going to create an EKS cluster using Terraform in a fully automated way, including all the landing zone resources that it requires to run. So this is my GitHub repo where all the code is. So basically I've forked it from HashiCorp. This is the guidelines which we're going to follow and verify, and this is my personal account where we're going to, as you can see, it's all empty, no clusters. We're going to go verify, uh, create the cluster and verify what the Terraform creates and basically validate. I just want to quickly show you before we do that. Make sure there's an empty cluster here, so I mean we don't have any clusters here. Let's quickly check the network components. You can see here, so it should be only a default VPC and without anything else. We'll give it a second. Right, so we're gonna also check the range. Taking a little longer than usual. Just give it a second, please. Right, there you go. So basically what we're going to do, we will execute this Terraform script to create. So these are the prerequisites which I've already installed on my terminal. And this everything will be again, shaded up for the demo, so don't worry about it. So this is what we're going to use, and this is basically a high-level architecture where how we're gonna create the cluster, and yeah. So any adjustments, we don't use Terraform Cloud for this demo, we use basically open source version of it, so I will show you when we're doing it. So there you go, so this is the default one, so which we will not use, and the Terraform will create another VPC, dedicated subnets for EKS cluster, and then basically we host the cluster in that new VPC. So there will be like 3 private subnets and 3 public, and then we're going to host EKS cluster there. Right, so now let's go also to the IAM just to make sure we don't have any roles apart from the default ones or service roles. So yeah, so there's no clusters, there's just the default VPCs, nothing else. And then the IAM, I would expect only the service IAM roles and no customized or roles. And we're going to kick off in our terminal in a bit. Okay, so let's go to roles. So here we go. So it's all service roles for EKS, no groups, auto scaling, la la la. So there's no basically custom roles that exist here, as you can see. But once we run the Terraform, it creates some IAM roles which are required, and a new VPC and subnets, and brand new cluster running here. Alright, as that said, so now let's go back to our terminal. So I would quickly, let me do a git pull. So there you go, it's all updated, and this is basically a clone from my repository. And all we need to do is you do a Terraform init to download all the required Terraform modules before we run. I'll just show you, it should already have the required modules, but I would like to run and show you. So what happens in the init process is basically it runs the required modules and save it locally. The error message you're seeing is because it's expecting a cloud organization, but we're not using Terraform Cloud. We use Terraform open source, so for that we need to edit this file. Let's comment out this section here. Like that. So basically we don't use Terraform Cloud, we use open source and with AWS provider. So we're going to create that in AWS. Okay, so that should fix that. So let's do an init again, just to make sure all the tracking modules are downloaded locally, and yeah. So now it's trying to initialize the provider plugins. It's successfully initialized. So now what we're going to do, we do a quick Terraform Cloud to see what resources Terraform creates, basically. So, and then we will do apply to actually create that. So Terraform Cloud basically doesn't create any resources in our AWS account. It just show you what resources that is going to create, and then based on your input, when you say Terraform apply, and then it creates the actual resources. So this is just basically going through all your Terraform modules, and it's telling you what, so as you can see at the end, so 55 to add, nothing to change, nothing to destroy, because it's just a new deployment. So as you can clearly see, so you can you have to run Terraform apply to actually create the resources. So that's what we're going to do now. So Terraform apply. Right, so what this is going to do, it creates a landing zone for the EKS cluster, like eVPC subnet, this network components, and required privileges to run the EKS cluster, and then it spin up the EKS cluster in that newly created VPC. So let's give it a minute, it just clicks up, there you go. So once you have this, when you apply, you need to confirm it by saying yes, I would like to perform the actions above and create those new resources in my AWS account. So now this connects to my AWS account from my laptop, and it's basically creating required modules that are required for creating a EKS cluster. So behind the scenes, we can just quickly check what's happening. So just refresh the EKS cluster. You can also see the output, as you can see here. So creation, ingress nodes, it's creating some rules, security groups, creating some route tables, subnets, yeah, a lot of stuff like that. So let's go to the landing zone. So here, if I quickly refresh, you should see new VPC. There you go, education VPC. And if you go into subnets, you should also able to see some newly created private and public subnets. There you go. So 3 public and 3 private. This is where we're going to create our EKS cluster. If we quickly check here, you should also be able to see some new rows created. But here you can also see security groups which are required for the EKS cluster. You can also follow it's creating a NAT gateway, doing some association with the route table. It's finished creating the subnets as we have seen it, and now it's creating the NAT gateway for the cluster. So here, let's see. So here you go. So that's our security groups. EKS cluster SG education. So these are all newly created security groups. And if you see also some route tables, you should see some of them. There you go. So, okay, 1 second. Yeah, these two. So there's another public and private route tables that we manage, and it associated the newly created subnets there. And if you go on the NAT, you should also be seeing NAT gateway. There you go. So it's pending. It's still in progress. So yeah, so it's behind the scenes, it's all getting created. You can see now newly created roles, education EKS, that's for the service EKS, so you're not using the default one, so it's going to be creating a new node group EKS to the roles. Uh, and if you go in the cluster, if you refresh quickly, I think it will be in progress. Yeah, there you go. So it's creating. Let's go back to console and check the status. It will take for sure 8-10 minutes to create the cluster with all the resources. But we just want to quickly show you some components here. So when it's all created, you get all the values here. So if you have 7 point certificate authority and stuff like that. So as you can see here, so the newly created IAM role is associated to the cluster. Uh, but again, all these values will be populated as it creates and stuff. So we're not running any pods. When it finished creating the node groups, you will see here the node groups up and running here. Uh, as you can see here, that's our newly created VPC, and these are our subnets, and this is our security group newly created one. So we're using public and private endpoint access in this example. So yeah, and we're using a Kubernetes version 1.24. So let's get back to the console and see. Yeah, it's in the process of creating all those aspects. So I want to quickly check the EC2 as well. Let's check the EC2. Okay. Here I'm basically checking if it created the node groups required instances. Oh, it will be in the process, it won't be ready, but let's have a look. We know it's all done here. We know we created the IAM rules and we're using them. So just see, the whole reason for this demo is to show you the power of automation. Yeah. So this is basically out of the box scripts which I'm trying to execute to create an EKS cluster in a completely new, in any AWS account, without any restriction. So this is the power of automation. Yeah. So Terraform really is very useful as an infrastructure as a code, and to create your resources, manage your resources on AWS cloud. This is really, yeah, cool. So if you go instances, I think it will be in the process of creating them. So nothing is running at the moment. So if I just clear the filter running, you might see some started creating, or yeah, okay, so it will start slowly. So we will see some music instances here once it's finished in our group. So here, as you can see, it's still creating a cluster components and associating as we execute. Yeah, so this will be refreshed and added with new EC2 worker nodes attached to it. Let's go back here. So that one is creating just to show you what it did, yeah, so far. So it also created a CloudWatch log group actually. That's interesting because it all the control plane also default goes to CloudWatch, and then in this CloudWatch log group, I will show you. You can open a cluster console and check what the log group is. EKS node group, we are basically creating an IAM role for that. We have seen these two roles. IAM policy, create that policy, so make sure maybe it has a least privilege attached to it or required privilege to it. And it also created a KNS key, which we use it for encryption for the at rest. We have a node group IAM policy attached to it. Yeah, VPC, route tables, subnets, public and private, updating the route tables, associating them to the subnets. Yeah, security groups. It also has created some rules, uh, and then it's also attached to its policy. So the roles, and it's created an art gateway for the outbound internet traffic, just to make sure it's secure. And now it's creating a cluster and associating all that components. So let's go back here again and just see what's going on. So let's see what's the node group is like, log group is in CloudWatch. So here is where you basically see all your control plane logs by default, and you can use either Prometheus or Grafana to collect the metrics for your control plane, API calls, and then also create some dashboard. And all the logging can also be exported to OpenSearch, and then you can basically search for any errors or anything for your for the development purposes. You can use OpenSearch as well. But the default is CloudWatch. So let's see what log group is created and yeah, how it looks. Just gonna quick refresh. It's still creating all the cluster components. So it takes a little bit time because behind the scenes, what it does is it creates an AWS environment instance which is not visible to us. It deploy all the Kubernetes this version and make our that server API endpoint available for us. So yeah, quite a work behind the scenes. If you consider all that, it's still, to be honest, yeah, fast enough, I would say. Okay, let's go to CloudWatch. Go to the logs. Go to log groups, and here I should be able to see the newly created log group for your EKS cluster. It's loading, 1 second. Okay, loading log groups. There you go. So AWS EKS education EKS cluster. So any of this logging that our cluster generates, it's basically creates a log stream like this. So Cube API, yeah, for API server, authenticator, so all the logs will be, we should be able to see here what's going on in the background. Should be able to search, yeah, create some alerts, yeah, anything on top of this. So while it's loading, let's see what's the status. Yeah, nearly 10 minutes. Should be nearly complete now. So as you can see here, you can see all the events Cube API server generates, and you should also be able to troubleshoot if something goes wrong. So this is the place where basically you check the control plane logs. And if you go back, you also have a log stream for authenticator. So any type of authentication issues, this is where you should be able to check out. So on the IAM roles, all those stuff like that. So this is where you basically can see what's going on. Cool. So we captured all the logs, the log groups to our cluster. We still creating the cluster. The landing zone is created where we're going to run the cluster. We have dedicated roles which we created for our cluster with the specific policies attached to it. I just want to quickly check the policy to make sure if there is any least privilege principle or okay, so someone like service, these are AWS managed policies or EKS cluster policy and resource. So AWS already customized and made it available for us. And this policy is basically what our Terraform created. I just want to see what that inline policy does. Additional to our AWS managed policies. Right, let's quickly go back to our cluster again and refresh. Yeah, I can see the server API available here. Let's go back to the resources and you can quickly check the resources. As you can see, yeah, so proxy is running, CodeDNS, AWS nodes, so which means if you go to compute, you will see your, yeah, there you go, pretty small, you have 3 worker nodes and you have 2 notebooks associated to it. So if I go to my EC view, I should be able to see my newly running worker nodes here. There you go. So we have our worker nodes up and running. And this you can control by your desired input to inputs to the notebook creation. Yeah, so you can basically customize how many worker nodes you need and how you want to scale up the using auto scaling group. It should also create an auto scaling group, and it associates to that our notebook. That's how it basically scale up, scale in, you know, depending on the resource utilization. Uh, I think, yeah, I quickly would like to show you what this, basically it created an extra inline policy to create a permission to create a log group and then deny everything else. So that's just implementing a least privilege principle. So that's good to know. So basically it's tightening up the security where what is required and limit the resources or permissions to um, yeah to the resources what is needed to be created. Yeah. So quickly out the scaling group here, as you can see. So our Terraform script also created 2 auto scaling groups and associated to our 2 node groups. And yeah, so it has 2 instances, one, and because our desired capacity is 1. So this basically reflects how many nodes you would like to run at any given point of time, and minimum at this, and max 3. So it means if your web resources are going up, you will it's basically spin up another instance here, and here we are saying it does the same. And we are scaling across 3 AGs here, as you can see. So yeah, if we quickly go to Terraform output, as you can clearly see, so all our resources are created, and it also gives you, there you go, output values. Okay, this is your endpoint for your cluster, that's your cluster name, that's your security group, and which region you're running your cluster on. So it's pretty neat, guys. Yeah. So using Terraform to create such a big Kubernetes cluster on AWS with all these components, notebooks, upscaling, IAM, security policies, your landing zone. It's yeah, it just and you can also adjust all these variables. Yeah, so into your desired capacity, and you can also adjust some of the components how you would like to host as well. Yeah, by editing your Terraform files, variable files, or something like that. But yeah, this is pretty neat. Your cluster is up and running. It took a little bit while, but I think it did the job. It's basically showing here you have a new Kubernetes version, and you can plan an upgrade or something. So new Kubernetes version available, and yeah, so 1.25. But this is pretty cool. So here you can in the EKS console client you can see what your resource capacity. So this is newly enhanced one, not newly, but yeah, they enhanced a little bit than since they launched. So all the ports you couldn't able to see in the past, and now you can see all the node ones, your compute, your basically network infrastructure, any add-ons you have, authentication. This basically you can also provide an yeah, for IDC identity providers and external ones if you have. Logging, so we turned on the API server or in an authenticator, so these logs you will be able to see in the CloudWatch. You can also turn on controller and scheduler as well, so that will create an extra log streams for them. Yeah, so this is how the power of Terraform in an automated way to create your EKS cluster on AWS. Okay, but how do we turn it down, Madhu? Because I don't want to get the cost for this POC. So what do you do? So basically you do a Terraform destroy and you enter. I mean, it basically gives you a warning, so it does straight away tear your cluster apart. It just analyzes your state file, what it created, and it gives you an output similar to that. Okay, you're going to destroy 55 resources, what I just created, and you want me to go ahead. And then once you say yes, your cluster, your infrastructure components here, landing zone, IAM roles, subnet, everything will be deleted, and including global cluster as well. So let's go ahead and see. So it's basically what it's doing in the background is it's checking your state file for what the resources it created in the past, and there you go. So 0 to add, 0 to change, 55 to destroy. So I say yes, please destroy, and because I don't need it. And now it connects to my API account. It rip off everything, and it's going to delete every single thing it's created. So let's go to let's see the state of the cluster while we're running it. So it basically will say instead of active, it should say deleting cluster or deleting. So 1 second, let's see, refresh. Maybe it started with something else. Okay, so let's go to the VPC. So this will be the last one to delete because the cluster is still running, so you can't just delete if you have an existing resources. So roles. So the state of the things should definitely change. So let's go back and see the output. Yeah, so as you can see, it's still destroying the node groups, destroying the route tables. Yeah, they're all in the process actually, so it's not completed yet. Behind the scenes, it's kicked off the process. So here, if I refresh, still active, but yeah, you see it's staying updating the capacity, but it's deleting it in the same. If I go for the subnet, this will be the last ones to clear off. So we have to refresh. It's doing the network components first, so then it will come. So let's do gateway created. Let's see. There you go. So it's deleted. And let's check the status again. Refresh. And let's do it here. Let's do another refresh here. So as you can see, the site capacity is 0. So now if I go to EC2, it should shut down my node worker nodes. So let's have a look. If it is for some reason, but yeah, it should also delete this log groups. But maybe at the end, it's starting with the infrastructure component, so that gateway is deleted, and at the end it will delete the VPC as well. Once all the resources and the VPC are freed up, it should delete all this newly created IAM roles as well. Let's go back and check what's going on. Yeah, it's doing the EC2 instances at the moment, not good. So if I go to EC2, you will see it shutting down or it's already terminated or something like that. So let's go here. Refresh. It's still showing active, but yeah, we know that it is deleting everything in the background. So yeah, you can see all zeros. That means your instances should be in the state of terminated or basically stopped. So there's no running instances. So if I clear this filter, you will see 3 instances with a terminated state or something. There you go. So we have 3 instances with terminated. So all these instances are terminated. Let's go back. You can see log group is inactive, so it's basically deleting it. 3 pieces at the end. It will gonna come in a bit. So let's refresh the cluster again. So let's go back to the outputs. Let's see what's doing. Yeah. So I terminate all the instances. It's destroying the node groups, and it's now destroying the cluster. So you should see your cluster is status as deleting or it disappears. So here, while we're here, I would like to refresh and see if, yeah, and remove the auto-scaling groups as well from here. Deleted. The instances will also be disappear actually, or it's terminated. Your log group is inactive. And your VPC will also disappear. So let's go here. Yeah, you see the status now is deleting. So cluster is still deleting. It takes some time. Let's go to rows. Let's see if it's deleted the rows. Yeah, I can see two are gone. So there's one more. It's deleting. So yeah, so it's pretty easy to create EKS cluster using Terraform on AWS using this Terraform script, which I'll share in my GitLab repo. And you have this one, and you have step-by-step instructions on how you basically would like to configure and run this here as well. But again, you can customize depending on your needs. Yeah. So it's pretty clean, pretty neat, pretty neat. If you want to learn how you want to migrate your Kubernetes clusters to AWS, run some pods, yeah, do some POC. This is a good start. Where you don't have to invest too much time creating your own scripts and running. So just basically clone your Git repo and then just kick off. To be honest, all you need is an AWS account. So here, let's go. Security groups we have also seen, right? So let's see if that's security groups also gone. All terminated. Refresh, so you can see it's inact. Yeah, all the log groups are gone. The VPC will be gone after it completely destroyed. Yeah, it's gone. So our VPC landing zone is gone. So if you see, that's the default VPC which we have before. So that's, yeah, all the subnets which we created are gone. So that means your cluster should also be gone. That's it. No cluster found. If you go back to clusters, and your cluster is gone. So that's it, guys. Yeah, so it's pretty neat. I created the landing zone where I want to run my EKS cluster. We created the EKS cluster, we verified all the components, and we destroyed every single component we created using Terraform destroy. And you don't have any charges after this, so it's all gone. So the security gates which we created, it's also cleared up, and yeah, nice and easy. Thanks, guys. That's all I would like to show you.